Okay, so in this graph we're going to be, or this lesson, we're going to be talking about asymptotes. Okay, and then we're also going to be graphing. So in this, you are going to want to use a graphing calculator to be able to graph them. What I'm going to do is I'm just going to show you the generic graphs of them, and then the domain and ranges and end behaviors, so that you guys can see the main parts of it, because you should be comfortable with using a graphing calculator. Okay, so an x squared graph, this is going to be a U shape, and the vertex is at 2, -3. And it's going to shoot off in these directions. So again, your table value you'll copy into the graph. So you just type in your equation, you get your table values, fill that out where you can get your graph. So my domain, furthest left that it goes is -infinity. Furthest right it goes is +infinity. So you should say all real numbers. My range then, the furthest down that it goes is -3 and it hits it, so it's going to include it. The furthest up that it goes is +infinity. And then we're going to do our end behavior. So the right side of the graph is going up, so +infinity. The left side of the graph is also going up, so +infinity again. Okay, my next one here is actually going to be a straight line. So what you can do is you would graph all the points to see where the straight line is going to be. So we got 2, 0, and then you would graph it. Okay, to get the equation here, we would get y equals, you could find the slope. So you would see from your graph how many you rise and how many you run. So you would actually rise 3 and 1, run once, and then it crosses your y-axis at +2. Okay, so if you graph it like how you're actually supposed to, you would rise 3, run 1. Okay, so my domain, it goes all the way left and all the way right for my x values, so all real numbers. My range, it goes all the way down and all the way up, so all real numbers. The right side of my graph is going up, so +infinity. The left side of my graph is going down, so -infinity. Okay, my next one is an absolute value, so make sure you get those absolute value bars in there when you're graphing it. The highest is going on this for the vertex, 1, 2, 3, 4, is going to be at 4. 1, 2, 3, 4. Okay, and it's going to come in a V shape like this when you graph it. Okay, so my domain, it's going left and right, so all real numbers. My range, it's going from -infinity and it stops. The highest it goes is 4 and it includes it. So the right side of my graph is going to -infinity. It's going down. The left side of my graph is also going down, so -infinity again. Okay, my next one, it's an exponential. So again, you would get your table. This one's going to be kind of ugly. It's going to have a lot of decimals. The main point, 1, 2, 3, 4, is up at 5. And it looks a little bit like this. Okay, so my domain, it is going all the way left and all the way right, so all real numbers. My range, it's continuing going down and continuing going up, so all real numbers again. The right side of my graph is going up, so +infinity. The left side of my graph is going down, so -infinity. And you'll be able to see that a lot better on your graphing calculator. Remember the y equals 3 to the x power, so you have to press the little caret button to get that little guy. Okay, my next one. Well, I'm sorry, this was actually the equation for y equals the cube root of x plus 5. Now I'm going to erase this and do the actual problem, so that was my fault. Okay, so this problem to the x power is going to start at 3, 0, and it's going to go up and down and get super close to 0. Okay, so I know it's going from +infinity on the right side and it's going downward to -infinity here. But it's actually, this one's a little tricky because it's actually not going to -infinity, it's getting closer to 0. So this one should be a 0 here. That's what's tricky about that. It's getting closer and closer to 0. Your domain, it's going all the way left, all the way right, so we're good with the all real numbers. My range, it gets closer and closer to 0, and it's going up to positive infinity. It does not hit 0, so it's going to be the parentheses. Okay, now we're on this one, so the rational function. Okay, so this one's going to have asymptotes. Asymptotes are basically these dashed imaginary lines that are walls that we can get really, really close to, but we're not going to run into it. Okay, so we have an imaginary line at positive 5 when we graph this. So y equals positive 5, 1, 2, 3, 4. So I'm going to show it by doing dashed lines. I'm not going to cross that, okay? And then at x equals negative 2. So basically, the picture of your graph should look something like this. They're getting very, very close to those dashed lines, but not touching it. Okay, so my domain, I'm going to do all of my x values. So it goes all the way from negative infinity to positive infinity, but the only one we can't include when we do this is negative 2. So x cannot equal negative 2. When we do our range then, my y cannot equal 5. So it goes up and down all the way, but they can't equal this. And then the next part of this is something you're going to see more in pre-calculus. Okay, so as x approaches the right side of my graph, my f of x is going to get closer and closer to positive 5. And then it's also, from the left side of my graph, going to get closer and closer to positive 5. But then you also have to include this weird negative 2. Okay, so as x approaches negative 2 from the positive side, the end behavior is it is going upward, so positive infinity. As x approaches negative 2 from the negative side, or the left side, f of x is going downward, so negative infinity. So you got to include like all of these walls when you do it. That you'll never see again until pre-calculus. Okay, write the equations of each asymptote for each graph. So remember, up and down is x equals, left to right is y equals. So we have x equals 2 and y equals negative 3. This one we have quite a few. So my up and down, I have x equals 1, 2, 3, 4, negative 5, positive 5, and y equals positive 2. Okay, this one I'm drawing them in, and then I am going to pick a color here that you could see, and then I'm going to write them. So there's one right here, and remember we always show them with dashed lines because they're not real lines, they're just these imaginary walls that we're not crossing. It doesn't look like we have any y equals, so horizontal ones. It looks like all of them are up and down. So all of these arrows that get really close to things but don't cross them. Okay, so we're going to have a lot of x equals. So x equals negative 2, positive 2, positive 6. I forgot this end one down here. Negative 6. Positive 10 and negative 10. And there were no horizontal ones that the arrows got closer and closer to. Okay, my next one. This does not count as one because it hits it. It also does not count this way because it hits it. You're looking for ones that get closer and closer to it but don't cross it. So this x equals, x equals 1, 2, 3, 4, 5 is going to be my only one in this because the other one hits where the actual line would be. Okay, given the asymptotes, write them in and then sketch graphs that would work. So x equals negative 5, 1, 2, 3, 4. Here's my x equals negative 5, and then my last one was y equals 1, and then you have to make sure you get closer and closer to them, and it passes the vertical line test. So here are my arrows getting closer and closer to them. You can do one in another department here, and it's not crossing them, but it passes my vertical line test everywhere I check it. My next one here, x equals 0, so we're actually on the origin line, and then also y equals 3. So again, gets closer and closer, closer and closer, passes my vertical line test. Okay, my next one, I got x equals 5, y equals -2. We're going to get closer and closer, but passes my vertical line test. The next one here, I got x equals 2, y equals 4, oops, and x equals -3. Okay, so we have multiple compartments that we can do it in. So if I just pick these ones here, I want one kind of in every compartment, and it will also still pass that vertical line test. Okay, I can't pick this one and this one because then they wouldn't pass, they would cross twice. Okay, so you want to pick the compartments that would make it so that they still pass the vertical line test.